And yeah, I can change my background once you send it to me.
Okay, yeah, I send it via messenger.
Oh, it might be loading still.
Oh,
That's all right.
okay,
Hey,
got it?
got it. Yep. Can you hear me okay now? I switched to my AirPods.
Yes, I can hear you and we are live.
Cool.
Hello, everyone. So welcome to our USACO training camp. This is the second day today, and we have our exam 3. So today is like a IOI kind of an exam, 5 hours, 3 problems. And I have Steven with me, Steven Hao.
Hi.
I'm going to introduce Steven to you right now, and then in 3 minutes, we're going to start our exam. Let me introduce him briefly. 1 second. Great. Yes, here is Steven. Steven is also a former IOI contestant. He got silver and gold medals in 2013, 2014. He has a degree, a BS degree in from MIT and in both CS and math. He's a software engineer at Scale AI. He was also a member of MIT team for ICPC in 2016. Great, I remember that time. So yeah, so you were with Andrew, right?
Yeah,
Steven?
Andrew and
Andrew
Brian.
in the team, yeah, I remember it. Yeah, it was a great contest, world finals. You guys did great, and yes, and he also taught at AlphaStar Academy, and he is also teaching World Basic course currently at AlphaStar Academy. Yes, we have 2 minutes. How are you, Steven? Are you ready?
Yeah, I'm ready.
I told you we have a lot of finalists.
That's cool.
Okay,
Yeah,
we'll see.
don't expect me to do as well as them. I'm kind of out of practice.
You're a great competitive programmer. Okay, no problems at all. So, but you will be surprised. I told you.
All right.
Okay, so we have 1 minute. Everybody get ready. So I need to send message to other guys from our Discord channel. And then Steven, I'm leaving the stage to you.
All right.
Stop sharing, and then it's all yours.
Sounds good. I'll just share my entire desktop then. Let me make sure I close out all my windows. Cool. Let's see. Desktop 1. This look good to you, Fatih?
Oh, nice. Wow. Okay, did you
Size
solve the
okay?
problems right away? So we haven't started yet. So you're so fast.
No, I'm cheating. IOI doesn't let you have book code, right?
Your template,
Is it okay
right?
if I keep my book code? I don't.
Yeah.
I
You
can't
can use
type
your
this from
templates.
scratch.
Right. You can use your templates. No problems.
This might be an unfair advantage because I hear they don't allow this anymore.
Okay. Yes.
All right.
The problem set should be available. Can you go down? Go down. Scroll down. Scroll down. Yeah. Great. Refresh it. Probably.
Oh, maybe I have to fill out something.
Oh, okay. Oh, good. Don't forget to read them. Okay, that's okay. So that's the regular LMS information, C++, Java, and so on and so forth.
Do I have to mark it as complete?
Okay.
Jump to exam 3. Here we go. This is it, right?
Okay, nice.
Okay, so 9:30, 23rd. That's today.
Okay, you can attempt.
All right,
Nice.
3 problems.
Okay, it's all yours. I don't want to distract you. Now I'm muting myself and leave the stage to Steven Hao.
All right. Well, these problems look pretty fun, Betty. A lot of them are. I've never seen any of these problems before. Where's the surprise?
You will see. Not yet.
Not yet. Okay. All right. Well, I'll just try to solve them then. Start with the last one. It looks the simplest. Maximum area obtained from defense. Okay.
I'm also turning off my video. So Steven, you're gonna be alone yourself.
Okay.
If you need anything, you can message me, via messenger or so, anytime.
Sounds good. Sounds good.
Okay, great.
I wonder how to solve this problem. It's interesting. It's interesting that this is a straight line. It might be just always a quadrilateral. Okay, geometry problems. I think one thing I can try is simulated annealing. The degrees of freedom are like n-2. And since I only need 2 decimal points, I can approximate it. Not sure if it's good enough though. There might also be a way to write out the expression in terms of the angles and then take some kind of derivative, like Lagrange multipliers maybe. Right. Okay, this seems like a DP problem. It's probably a convexity DP. Okay, DP. Hmm. Notebook code means I have to write my own line container. I did not prepare for this. Okay, here's my formula. And since this is, I think this is no penalty and full feedback, so I might as well just submit an n squared for this. N is, what is n? It doesn't say what n is. Why can't you tell me what n is? I need to know. Submit clarification. Oh, that's not how you do it. Okay, can I submit this? Test data not shown. Okay, well, okay, let's find out if this is okay. No, it doesn't even tell you what status code you have. All right, that's pretty fast. So there's probably no 100,000. Okay, let's see 10,000. All right, there's probably n's that are greater than 10,000 because this is very slow. Okay, so let's just do the convexity DP thing. Oh, it tells me TLEs. Okay, great. Yeah, I can't do this. I'm just gonna have to cheat a bit and copy a line container from capital. Don't do this at home, kids. But we are going to use this thing. So I corresponds to a line. Else line dot add. So K is going to be M sub I, and then M is going to be dp I plus p minus, and then J is dp. And then that's after we compute the dp. dpi is dot query dpi, and then answer and container dot query. What is it asking for? K days. So K plus 1. Is it K plus 1? Yeah, K plus 1. I'm not sure if it's K plus 1 or K plus 2 anymore. Oh, I think this is wrong. I think it's DI plus 1. That makes sense. Or, I could just do DI minus 1 here. I think it's the same thing. Okay, let's just try this out. So line container. Is this line container dot query K plus 1 or K? I think it's K because you have to spend the last day selling your thing. Do you have to sell your machine at the end? So it doesn't say if you have to sell at the end or not. What does how much money he can afford mean? Yeah, I'm just gonna assume you have to sell your machine off. Okay. I think this is correct. Are the DIs sorted? DPRM. I'm gonna sort it. Now reiterate through. Okay, so now we do the thing. Container.add 0c dp I. I don't really need to store it. Might as well store it. So this is line container query. And then we line container.add dpi. This is only if dpi is dpi. And then ans is print it out. All right, let's try it. Printing out the wrong answer. That's all right. That's all right. I didn't want it to be right anyway. My R and P are swapped. Try again. Please, 72. Well, the best thing about these IOI style contests is that you get infinite submissions. This is not ideal. This is really not ideal. So it doesn't like how I'm calling implicit things in my line container because it failed to extend okay, what is all this? Multi-set. Is it that? Is that all I have to do? Expected class name. Line. Less. Okay, let's delete the Y Combinator stuff and resubmit. And maybe I can try using C++11 to make sure it compiles. Nope, it doesn't compile. Oh my God. This is a less doesn't like 0. Okay. So I think it's because I'm being too fancy. Aha, now that's a bit better. Lower bound. Oh, what? How? What? What's going on? Okay, I thoroughly regret using book code now, but think what I have to do here is okay, no, I have no idea. I have no idea how this code even works. Lower bound X, erase Y. What is Y? Insert KM0. Oh, because it supports this operator. So C++ less. What exactly is it supposed to be? This is so much more work than it should have been. So I think you're just not allowed to do multi-set, like query for non-line objects. You just can't do lower bound on things that aren't lines. So what we're gonna do is have a flag here. And let's say, flag turn P less than O dot K. What is P? So turn this and then delete that, and then look at this. 0, 0, X, 1. Does this still work? Still works. Green? Green? Can you meet the green? All right. Passed all tests. To anyone watching out there, I just had to learn about C++11 template types and how they differ from C++14. So that's always fun. We're gonna move on to the next problem. I haven't read this CalNet problem yet, so I'll read it first and then choose either that or the defense thing. So the total bandwidth is like, I can't tell. bandwidth cost. All barns in the same group are communicating with each other, but not to itself. So it's like 1 talks to 2, 1 talks to 5. And then 2 talks to 1, and 5 talks to 1, 2 talks to 5, 5 talks to 2, 4, 3, 3, 4. So that would be 8 pairs. On average, it's like 5. Sounds about right, but maybe a bit too high. Let's reread the problem. I don't think I understand how communication works. So are these one-way channels? Okay, one-way channels. 2 barns in the same group communicate. First reaches the server. It's always possible to communicate between any 2 barns. I mean, putting aside me not understanding the problem statement, seems like you'd want to run Dijkstra. Run Dijkstra twice on the original graph and then the reversed graph. And then you want to do some kind of, is it greedy? What's the limits again? 5,000. Yeah, 5,000 numbers. Yeah, 5,000 barns, each of which has a forward distance and a backward distance to the server. And its cost is gonna, you can just add them up, huh? Yeah, it has a distance, which is the sum of its forward and backward distance. Basically, you sort it and draw lines. Yeah, I think that's it. Sort it and draw lines. Okay, so the distance for 1 is 1 plus 1 is 2. Distance for 2 is 2 plus 5 is 7. Let's write this down. Use Jamboard. It's all my lectures. But I'll name this one, what's it called? Count it. Or exam. Scratch. Okay. We'll even have the A-star logo. Okay, so here we go. Here we go. We got 2 over here. No, this is 2. This is 2 plus 5 is 7. This is probably the same because it's the same path. Yeah, and I can already tell that the answer cannot be what I'm thinking, because why would 1 and 2 be in the same group? I must be missing something. Whatever. 3 and how do we get here? 12. The cycle for this is the same thing. That's 12. So 2, 7, 7, 12, 12. divide it into two groups. I would have thought it's like this, so that you do 2 times 2 plus 7 plus 7 times 2, and this times 1, and that would make 32 plus 24 equals 56. That's my answer. But they say the answer is 43. So clearly I'm missing something. What am I missing? Is it possible to submit more clarifications? I might come back to this one. Like, I think I know how to solve it, but clearly I don't. So the issue is that I don't understand the problem. Maybe the diagram is, no, the diagram looks correct. Oh, wait, no, they forgot to draw this one. 561. I'm so confused. They changed the input. They changed the samples to not have 352. Instead it has 561. And that changes everything, doesn't it? So instead of 12, now this one is 5. Okay. So maybe 7 and 5 instead. So this is 28. This is 19. And 47. Oh, still not quite there. Well, I think this one goes down a bit as well. So these go down. Why is this one 12? 2253. Yeah. 1, 2, 3, 5, 1, 2, 3, 1, 1. 2, 2, 1. Aha. So this 7 actually becomes 2, 2, 1. It's 5 now. And that still does not fix it. Oh, it does fix it. Okay, we're good. This is 24. It's 43. Okay. So we're now given an array. Given an array, draw k minus 1 dividers, k groups. And then the dp is probably somewhat, okay, it's, and you can just do an n squared dp here. So dpi, it's not that straightforward, is it? It's the same code, but P and K. Solve problem for n prefix. Okay. Okay, so it's probably a recurrence. And then 5,000 times what is max K? K groups. K is less than 50. Oh no, that's only for person. Okay, so let's write this down. It's surprising to me that there'd be two problems that are so similar to each other on the same set. Cheese production and COUNTNET both kind of boil down to the same trick at the end, it feels. Well, I guess I haven't solved this one yet, but it feels like it's going to be convexity again. I could be wrong. Could be wrong. All right, so. Okay, maybe this problem isn't as simple as I thought. There should be some observations we can make, like greedy-like observations that drastically reduce the number of options we have to consider when placing these dividers. Like, for example, my AirPods running out of battery. Oh, geez. My AirPods are running out of battery. It's not good. going to use this powerful technique in algorithms known as the power of two choices. In particular, I'm going to charge one of my AirPods while I use the other one. And then I can switch back and forth and they will never run out of battery. In theory. We'll see what happens. Okay, I still need to solve this DP problem. Fatih, if you're listening, you may want to update this diagram because it's missing an edge and it has an extraneous edge. Yeah, so why is this DP not just straightforward? It's because of reasons. It's because of reasons. Because both n and the prefix sum up to n are linear components of the dp value of n given a fixed I choice, given a fixed choice of where you're cutting off. Yeah, that sounds about right. But there's the observation that the groups should only get smaller. And that, I think, is a huge observation that can turn this instantly into n squared. The group should only get smaller because why wouldn't they? Like, why would you have a bigger group at the end? Because that sum is going to be larger than the previous one. Yeah, it never makes sense to go from small to big because you could just move this over and everything gets better. Yeah, I'd buy it. Hey,
Hi,
Fatih.
Steven. Yeah, I apologize for the first problem. So it should be fixed right now. Can you, if you refresh the page, you will see the right diagram.
Yeah, I see it now.
Can you, is it right?
Yep.
Okay.
Yeah, that looks good.
Okay. So is everything fine with the problem right now?
Yeah, I think so.
Okay. Okay, great.
Thanks, Fatih. That was really
Sorry,
quick.
so you already fixed it for the audience. Thank you very much.
Yeah, of course. Yeah, I think, anyway, back to my train of thought. Group sizes, non-increasing group sizes as you go from left to right. I want to double check that one more time. I think it's even enough to say that if it does increase, it only increases by 1. I think that would still help a lot. Why would that even help? Something about it just constrains a number of ways to partition it. That's the short story of it. So you add a dimension. But once you add a dimension, that isn't n squared anymore. Okay, I'm gonna mute myself and just think for 5 minutes. All right. I think I have the answer. The answer is you do dpnk. Answer. Prefix. And then dpnk equals, what did I write here? Max min over all I. Yes, and then. Okay, it's not less than that. Let's say low less than I less than plus minus 1 times so I guess sort or low equals n minus another k. And the reason is, this might be floor, I think. Yeah. The reason is your group sizes need to be non-increasing as you go from left to right. So if you're considering a suffix, it can't be more than n over k. The kth group cannot be larger than n over k. So this gives you some n over k. Consider sum over n, k of n over k equals n squared log n. And that is probably going to pass 5,000 squared times log n, which is like 13. 13 times 5,000 squared, 300 million. It'll be a bit tight. We have 2 seconds. I think it'll be okay. And I'll say this is something around 100 mil. It might be even smaller, actually. It's probably going to pass. Okay, so let's just start coding then. And P and KM, or P. So P is hub. Okay, so now we want to DFS twice. So let's do int dist. Let's just do like sum. Or let's call it val. We'll reverse the graph here. What's it called? I'll do it this way. Okay, and then we'll swap. Now we run Dijkstra. We build the graph first, now we run Dijkstra. And what is the first one? 0 is n. Then long pq.mt. I forget exactly how Dijkstra works, to be honest. You start at infinity. This is a small optimization, I think. Okay. To have a P already? P. Just like that. Beautiful. And now we need our infinity. 10,000 times 50,000 is 500. Pi, pi, greater pi, pq. If we're visited. All right. Now we need to do this thing. Val I plus this thing. Now finally sort val. Now we run the DP. Let's first make sure these values are correct before continuing. Segmentation fault. Why would that be? It's probably because I'm doing something wrong. So this must be P, right? P and KN, yeah. Anything else that needs to be P? Two, 4, 6, 2, 2. What did I write here? No, that's not what I wrote here. Yeah, something's off. Something's not right. Three, 0. Oh, did I do something silly? U, B, and C. Yeah, I'm definitely not reading the input correctly. My U's, V's, and C's are all wrong. Oh, this needs to be M. There we go. 24642, that's still wrong, but I'm just gonna use the B's and C's are correct now. So my Dijkstra is not doing its job. This really shouldn't be so hard. I'm getting confused by all the numbers. Oh, because of course, why am I connecting it both ways? Okay, 2, 5, 12, 7, 5. Now those are the numbers I want. Okay. So what did I say earlier? Let's move this down. Okay. How does this work again? Minimum total bandwidth, best possible way. And the bounds are such that the individual distances are integers, but once you multiply them, they'll be long longs. Okay. So let's start with 1. And let's do it. Yeah, let's do like this. So here we're going to set this. And that should cover everything. And then we compute low now. This is I over J. Okay, so we're going to go for int. I need a new variable. Okay. So now we just do it. So dp x j minus 1 plus, what are all these numbers? I minus x minus 1 times prefix minus prefix. What is the prefix here? It's I and x. Okay, so I need to pre-compute some prefixes, no biggie. And I need LL into all. It's a big number. Let me double check this. So it's exactly K groups, right? K is always less than N. I'm going to guess that K is less than N. Yeah, K's got to be less than N. Why wouldn't it be less than N? So this is less than I. Let's just try it, you know? What's the worst that could happen? That could happen. That could happen. Let's initialize this thing. And P. It's just dp 0, 0 equals 0. Let's see if that fixes things. It does. I don't know what I did, but I fixed it. Checking, runtime error. That's unfortunate. That is very unfortunate. Is my memory allocation too large? What else could it be, right? So I need to do some trickery where I just make this 2. That's not right. I can't do that. It's hopeless. It's hopeless. Maybe I iterate over K first. Oh, why is the memory constraint so tight? Oh my God. Why do they do this to me? 256. Long is 8 bytes. So this gives me 32 bytes, or 32 million. This is 5 times 5. That's 25 million. So it should fit. These are all tiny, right? M is 50,000. That's tiny. I have 25 million longs. Why is the runtime erroring? Am I doing some invalid accesses? Seems good enough. Runtime error. I feel like the only way runtime error could happen is memory limits being exceeded. Is my Dijkstra wrong somehow? I don't believe it. I don't believe that my Dijkstra could be wrong. Do I really have to optimize this memory? I can swap the orders of this, I guess. And this is just 2 now. Oh my God.
Steven.
Yeah.
So you're using local variables, right?
Oh, I see.
So there might be a problem with LMS. It's just for LMS. Text segment might be, I'm suspicious about it in C++.
Yeah, I think I've seen this before too. So I just have to do this, right?
Yeah, that's not, yeah, that's related to LMS issues.
Okay, yeah, I think that should do the trick. Thank you.
I'm not sure about it. I'm just guessing it.
No, that sounds right to me. I've had a student run into the same issue. Okay, maybe not. It's okay. I can fix this. Yeah, I'm just gonna only store the last 2 layers of the DP. And it works. Yeah, I think there might be, I might just not fit in the memory limit, which is a bit surprising, but it's okay. Well, we got that problem out of the way. 10 out of 10. So we just have 1 problem to go. Oh, unfortunately, this last problem is really hard. So it's unclear if I'll be able to solve this in the remaining time. We started at 9:30, so we have around 4 hours left. But since this is a geometry problem, it might not be enough. Yeah. Let's maybe take a lunch break soon. Oh, I need to order food. Honestly, I would do anything to not have to solve this problem because it just sounds so hard. I feel like it's not meant to be solved heuristically, but I also feel like it can be solved heuristically. Just like I'm imagining like the natural process of like trying to inflate this object and seeing where it can like adjust to accommodate more area. Kind of like bubbles become spheres. Yeah, I don't know if that makes any sense. Is this even 100? Is this straight at all? Like, should it be straight? Why should it be straight? Why should it be straight? No, it should definitely be straight, yeah. Is it always a quadrilateral? I think it is. Because I don't have a good reason. Of course, it's not a quadrilateral. If all the sides are equal, it's going to be a regular polygon. What am I talking about? You want it to be as close to regular as possible. That sounds more like it. As close to regular as possible. But this is not very close to regular. Wouldn't a pentagon be far more regular than this? Yeah, I'm gonna have to hack this problem because they only want 2 decimal points. I guess now would be a good time to read that, read the rules. Make sure I'm allowed to use heuristics. Aha, I should have read this. I don't know what this means. Do I have to submit things specially? Oh, 1 attempt for the exam means I can't restart my clock. Okay. Hmm. How do I solve the problem for n equals 4? Would it be a cyclic quadrilateral? I think basically we're going to want to look at angles. I don't know how. Yeah, I have no idea how to solve this problem. I really like the idea of simulated annealing, so I might just do that. All right, my new AirPod. I don't think it's completely straight. I think there's an angle there. It just looks really straight because it's close to 0. What is the formula for an area of a polygon? You probably just want to do the triangulation thing. How does the area, the optimal area, vary with a single side length? When it's 0, as it approaches infinity, the area definitely becomes 0. Because if one side is too long, it's a bad thing. But is it? bitonic? Is it like goes up and goes down? It definitely increases as you go up from 0. But then does it go up and down? I think it's bitonic. I think it's like starts at some constant, goes up a bit, and then goes down. What does that tell me? What does that tell me? Okay, I need to solve this for n equals 4. And then I think if I can come up with a clean condition for whether or not a foregone is optimal area, given this side lengths, well, every single foregone in the n-gon has to be optimal. So my intuition right now is like this quadrilateral, A, B, C, D, E, F. I'm saying that ABCD must be optimal because moving around B and C impact the rest. And the same is true for every quadrilateral. So how do you find the optimal quadrilateral given its 4 sides? Given 4 sides, the optimal quadrilateral, I mean, you can compute it explicitly in terms of any of the angles. There's probably a formula you can just use. And then I think the answer is just keep fixing quadrilaterals until you've fixed all of them, because every single step you're increasing the area. And surely this process will converge. I think is it true that if every quadrilateral is optimal, then the whole polygon is optimal? That seems like a stretch, but it might be true. It might be true. I think I gotta be an engineer here and just prove it by getting AC. Proof by AC. What is the area of a quadrilateral? Is it just when it's cyclic? Is that when it's optimal? Because it does not look cyclic in any sense of that word. None of these quadrilaterals look cyclic. This isn't even a diagram of the optimal one, right? Yeah, this is not optimal at all. This is just an example. Why did I think it was optimal? Okay, so cyclic quad given its sides. Why is it cyclic? Who knows? It just feels like it's got to be cyclic. Yeah, I'm just going to believe that it's cyclic. So, wait, but then doesn't that mean the whole polygon is cyclic? Is that the answer? am I really overthinking this? It might just actually be that. Oh, Steven, why did you overthink this so much? All right. Let's just do this cyclic thing. It's going to be a circle. Given a fixed circle, it's easy to compute the angle of any length. This is just going to be our, what is it? Arc sine of x over 2 over r. X over 2r. Arc sine of x over 2r times 2. Okay. Yeah, this might have been an easier way to look at it. Okay, arc sine of x over 2r. And we can binary search on the radius. Lengths. Well, the total perimeter is bounded by 500,000. So that means the radius cannot be greater than 500,000. Okay. So go just add. So okay means sum of angles is less than 360. 2 pi. Let's say 2 pi. If it's okay, the sum of angles is greater than, then we need to get bigger. And then we need to compute the area. Okay. So let's just getting this is just going to be, what is it, 2 times a sine x over 2 times r. Do I have pi already? Double pi. Okay. And then the answer, what's the area of each individual section? The area is x base times height. The height is cosine of x over 2. Cosine theta over 2 times x over 2. So this is the area. Sorry, this is getting. Okay. Double. 13.7 Steven, and that is not anywhere close to 13.7. I don't know why my answers are wrong, but let's print out some stuff. Okay, let's try with a hexagon. 2, 2, 2, 2, 2, 2. A regular hexagon with a bunch of 2's should have a rate area of 6 times square root 3. But my answer is about half that. So where did I go wrong? Maybe it's this. I forgot to multiply by r. Well, that could be it. That could do it. Yeah, r times cosine theta over 13.7. All right, there we go. So is that the right syntax? Please pass. Please. Oh, I did not pass. Rounded to the nearest 100. That's what set precision does. Yeah, okay. So something's wrong. I know just the solution. We're gonna eat some Chipotle. Did I submit the wrong code? Oh no, I just left in my big array. So I have no idea why it's not passing. But if I had to guess, it's either because I messed up my code or I messed up my math. Maybe I can start R at max v over 2. Would that be a good idea? Because I don't really know what happens when you pass in something larger. Then 1 to a sign. I could print that out. Okay, a sign 2. Nan. That could cause an issue. So let's try this again. All right, baby steps, baby steps. Surely a billion iterations are enough to get 2 decimal points. Like, I'm not sure, but like surely they are. I mean, at the same time, it doesn't really hurt to double this. Okay, but there's probably a bigger issue. Maybe I need LD. Okay. No way this does anything now. Like, this is not my bug. No way this is my bug. 500,000? It's gotta be big enough, right? It's definitely big enough. This is something I'm slightly concerned about, but maybe I can try it on what should I try it on? Decagon. How about 12gon? Three R squared. Okay. How do decagons work? Dodecagons, 30 degrees each. So this is going to be sine 15 times 2. Yeah, sine 15 times this. Yeah, that sounds right. Wow, Google doesn't do degrees by default. What? Okay, my code is correct. That means if this still doesn't pass, it's my math that's wrong. So let's give it one more try. Yep, this is with LD. And then I'll double check the cyclic quad stuff. With every new submission, I get some more test cases. That's so strange. All I did this time was change it to long double. Maybe I need to round it. That might be the issue. Well, let's find out. What am I doing? No, it does round. Separation does do rounding. Right? Yeah, this is this is downvote. Number should be rounded to the nearest hundredth. That's what I'm doing. Okay, let's review. Why is the area of a quadrilateral maximized when it's a cyclic quadrilateral? I'm not a very good mathematician, but I do know Brahmagupta's formula for areas of cyclic quadrilaterals. Brahmagupta, my good friend, once said that if the diagonals of a cyclic quad are x and y, then the area is, oh, I forgot it. Oh man, it's something like this. Something along those lines. But I'm no Brahmagupta. I cannot prove anything like this. Okay. Is it even plausible that they would put a problem that requires such a important mathematical insights to solve, yet have it be hard to prove? I don't think so. I don't think they would put a problem like this on if it weren't easy to prove. So we should try to prove it. But even if I prove it successfully, what good will that do? I still don't know where my bug is. And what are the odds that I pass half the test cases if this isn't even true? So cyclic quad. In a cyclic quadrilateral, these angles are supplementary. Opposite angles are supplementary. They add up to 180. Why might that be useful? Like if you had a really not cyclic quadrilateral, like a parallelogram, where the angles are way bigger than 180, you'd want it to like become less skew. Because the area of each of the two triangles increases. You're making both the angles closer to 90 when you do this. So is that a proof? I don't think it's a proof. Is there an argument I can do about affine transforms? Doubt it. Doubt it. Either way, I'm pretty convinced that it's true. Rounded to the nearest hundredth. I'm pretty sure that's what I'm doing. But let's try this. Let's try this just for sake of gaining information. So we'll take notes here. This one is when I did this. I got this. Now let's try this. Let's see what I get this time. Now I get everything incorrect. So that is very concerning. That indicates to me that I should just do this. Nope. Okay, that's really weird. How come this didn't affect anything? That makes no sense. That makes no sense. Something is up. Something spooky is going on. Does this make any sense to you? Why it would do this? I'm not crazy, am I? If I do this again, it's still going to be the same thing. You are kidding me. So what if I do this? Nope. That's not it. Okay, what does this tell us? We know that printing it out rounds it. I'm thoroughly stumped. Okay, what about this? Is my cosine incorrect? Oh, it might be. Nah. A sine will always return a number between 0 and 90. When you divide it by 2, it's still between 0 and 90, so it's positive. Could it be that they want me to pronounce 0 if it's degenerate? Like, it doesn't say what to do in that case. So I guess, I guess we could do that. But it's really not even 0. But I suppose I might as well. Think that. No change. Yeah, I might just give up on this. I have no way of proceeding. Oh shoot, I didn't mean to click that. My score is 2.5 out of 3 right now. I still have close to 3 hours. No reason to finish it right now. But I am getting close to giving up. I have no explanations for why this is what I'm seeing. I guess we can just try to prove the cyclic quad thing. All right, I'm ready to solve this problem. I'm going to first prove that a cyclic quad is optimal. Circles. Circles. I don't understand this thing about many different areas. How do you have many different areas? don't understand. Maybe I just don't understand how fences work. What does flag mean? I don't think it does anything. That's a problem. Oh, it's not a problem. Ooh. I don't know. These are integers, right? Yep, they're integers. Maybe I can ask a clarification. What if because right now I put out 0. Maybe it's better to do this. It's probably not the issue though. What would happen if I just did 6 here? This would just fail. I'm sure it's going to fail. This should all be right. Yeah. I am at the end of my wits. I've tried everything I know how to do. All right, guys. I'm about ready to give up. All right, so this is definitely cheating, but I'm going to call my friend and ask him for some suggestions. Yeah, this is probably not allowed, but I think Fatih gave me permission, so I'm going to call Andrew He.
Yeah, no problem.
Should I invite him to the Zoom, or should I just try to call him?
He can come to the Zoom. Yeah, it's gonna be more fun.
Okay. Hey, Andrew.
All right, let me mute your screen because.
Do you actually want to join the Zoom? So it might make it easier to stream and stuff. I'll send you the link. Yeah.
Okay.
But yeah, I'm pretty stuck on this problem. I'm pretty sure I've tried everything I know already. So.
Did you handle the 111 2.5 case? Like 1112 is like the 2 is the diameter, but like 111 2.5 is like 2 is like past the diameter on the top side. Like 111 2.5 does not include the center in its interior.
I see. So I need to use signed areas, don't I?
Well, like first you need to identify it, and I think you identify it by like checking whether like you get it the diameter works, it's too big or too small, and then you have the special case to.
Yeah, I did not handle the case. Oh. Yeah, you're right, Andrew. So I'll stop my share for now.
Yeah, that's probably the case you're not handling.
In my diagram, I think I assumed that the center was inside the quadrilateral. So it's still true that it's cyclic, but the formula just needs to be a bit different.
Yeah. You just need a special case, the biggest edge. Like it just depends on, like I think what you do is you first test the biggest edge to see if it's like you test with the radius equals to the biggest edge over 2, and if that's too if it's too big, then the center is inside, and if it's too small, the center is outside. And then if the center is outside, you just like for that longest edge, like the edge has to be way longer than everything else, right? So for that longest edge, you use like a negative angle instead of the positive angle, or like the reflex angle. Like you do 360 minus the angle or the sine or whatever.
Well, I don't know if the radius will tell you. The relationship between the radius and the biggest edge does not actually tell you what you need to know about the orientation.
What you do is you test exactly when the radius when the diameter equals to the biggest edge. So.
Oh, I see. And then that will tell you.
Yeah, that will tell you whether it's up or like whether it's whether you need to like shift it upwards, in which case like it's like the center is inside, or like outside, or you shift it downwards, in which case the center is outside, or whatever. I don't know, whichever sign convention you use. But that's the easiest way to test. This is a very classical problem, right?
I mean, I've never done it before.
I first saw this in Putnam seminar at MIT.
Oh, okay.
They gave a proof of it. Do you know the proof? It's cyclic.
I've been trying to prove it for the past 2 hours, and I'm not good enough at I don't even know like trigonometry or just geometry.
There's a really funny proof, which is like, first of all, like there is a unique way to like consider the way of embedding this thing in the circle. Okay. And then like, you know how like there's an arc or like a little sector attached, I don't know, a loon attached to each side.
Yeah.
Consider any other arrangement of the polygon, but with the same sectors attached to each of the sides. All right.
Okay.
So that new shape has the same perimeter as the circle. It might have some self-intersections, in which case its area is even smaller. But as we all know, for a given perimeter, the maximum area is the circle. So
Oh, that's really clever.
yeah, so kind of like by assuming that the circle exists, you can kind of like attach on the circle even when it's not actually there, and then like prove that it's better that way.
That's a really good proof. How do I start a drawing in Zoom?
I don't know. Maybe a whiteboard or something.
So what are you trying to do?
Oh, it's all right. Oh, I think I know how to do it actually. Whiteboard, yeah. So you're saying if you have cyclic quadrilateral.
Yeah.
Oh my God, this is so hard. You have a cyclic quad, right?
Yeah.
And then you're saying you break this up into like these A, B, C, D.
Right. And if you draw a different like skewed quadrilateral with side lengths A, B, C, D, you like keep the things attached to it.
That's really clever.
Yeah.
And then any other configuration of A, B, C, D.
Yeah, it'll look like it'll have the arcs, but the arcs like won't make a circle. And it'll have the same perimeter as the circle though. So it will that will be worse than the circle.
Okay.
Yeah.
I see. Okay, so I just need to handle the convex case, or I don't even know what it's called. Just the case where one of the angles is greater than 180.
Yeah, it's It's the case where like the center is outside the circle or whatever. The center is outside the quadrilateral or whatever. Yeah, reflex. I don't know what exactly you call it, but
Obtuse?
you can just handle it in the start at the start. In fact, in that case, you actually need to like binary, like your binary search actually goes the other way. Like as your circle grows, like yeah, it's kind of weird.
Yeah, this changes all the assumptions I made in my code. I'm gonna have to start over.
Well, you just have to like you actually kind of just have to do two cases. Like you kind of just have to copy paste your code a second time.
Yeah, no, that sounds right. Do you have any idea why when I subtracted 0.005, the correctness of my answers didn't change?
I have no idea, dude.
Does that basically mean like rounding and flooring was always equivalent? Like the problem said to round it, but if you floored it, it would have passed as well, or like it doesn't affect it for some reason.
Yeah, maybe. I don't know. I guess it just like maybe it's within relative precision or something.
No, because when I added 0.005, it started failing.
I don't know. Maybe you're just like just on the edge of the precision boundary or something. I don't know.
No, I think maybe it's like the test case curation was like they only pick things that had this property of it doesn't matter if you round or floor.
Oh, interesting. Oh, that's possible. Yeah.
Yeah, I think that's possible.
Regardless, yeah, you should be able to get a pretty precise answer. So shouldn't be a huge issue.
All right. Well, I'm going to switch back to coding then.
Yeah.
Thanks for the proof. I like the proof a lot.
Yeah, the proof is kind of, it feels like you're cheating, but it works.
Okay, so let me think through this. How do I check for this extreme case? So you said that I just need to do something like assume this is the longest edge. There's two cases. In one case, it's an obtuse triangle. In the other case, it's an acute triangle. One case, it's greater than 90. In case, it's less than 90. Yeah. But it's not a triangle. Well, this is still going to be, I guess.
Yeah, I think a good test case is 1112.5. Like that's 1112 is a hexagon, right?
Yep.
Is a regular hexagon. So 1112.5 is like a little longer than that. So you'll test this case.
Right.
And it still satisfies like triangle inequality.
I see. So basically, if we try to do one, like it works perfectly when this is the diameter, when it's 1112. But if it's like 1.7.7, it's not going to reach it. There's going to be a gap. Okay. And if there's a gap, that means that this guy needs to be obtuse. It needs to be on the other side. And then the binary search goes backwards.
Yeah, it's just like the sign goes the other way. Yeah, like essentially like you're trying to making the circle bigger closes the gap, right?
Mm-hmm.
Yeah. So it's just backwards relative to the other case. Just the way it is.
Okay, I guess I'll just write two versions of the same code. Yeah, I'll clean this up, but
I think I've implemented this once before or something, and you can like do a couple things to make it like you can reuse some of your code, but other code you can't really reuse. So, I don't know. Just like maybe you can reuse your like get angle, or like you can reuse the stuff where you sum up the angles and stuff, but beyond that, you can't really reuse much. You also do have to special case on which edge is the biggest one. So there's that.
Yeah, I'm just gonna take it out of my array.
Yeah.
Vary R, and then if sum of angles of V plus angle of MX greater than 2 pi, then that means that my circle get bigger. Oh, small. And here, if sum of angles of V greater than angle of MX, R needs to get bigger. Like, is it bigger or smaller? It's unclear. Like, doesn't this have to do with the shape of arcsine?
Yeah.
It's not, I'm not sure it's like a straightforward binary search anymore. I have to use Jensen's, right?
Sorry, it's still binary search, but it's just not like the same direction. It still is monotonic.
But it's monotonic because of Jensen's.
I mean, the other one is also kind of monotonic because of Jensen, right?
No, that one's monotonic because arcsine is monotonic.
I think that's the same.
What?
Okay, maybe it's different.
Okay, what is, so arcsine, sine of 0 is 0.
You're just saying you have to prove that you just have to prove that the big edge like grows, like takes up less area faster than the rest, right? Or something. And that's Jensen, like taking the slopes or something.
Yeah, that's what I'm saying, but like,
yeah,
I'm not really much of a, I'm not a mathematician, so.
But I mean, if you just think about the circle and the circle gets bigger, like, come on, the biggest one has to like intersect it at some point.
Like, as the circle becomes infinitely large, you can handle.
Well, it just becomes triangle inequality. It just becomes a degenerate quadrilateral, like polygon. You approach triangle inequality limit.
Yeah. So as R gets really big, your all these angles just become 0.
Yeah. I mean, you're right that it's not just like some monotonic things is monotonic, but the proof is pretty.
Like
proof is pretty.
it either requires a lot of intuition about angles and circles and geometry, or you have to use Jensen's. It's one of the two.
Yeah, I guess it's just Jensen.
Okay, well, I still need to figure out if R needs to get bigger or smaller here. Give me a sec. Okay, well, let's actually start by if R equals mx over 2 and sum of angles of V is greater than 2 pi or greater than angle of mx. So that was, we're talking about this case. So then case 1. Otherwise, then case 2. Okay, I think it's just this. So why is it, what do you mean by it's backwards? Like it's not actually backwards. R is just getting bigger as long as the sum of your small things. I forgot what Jensen's inequality was already. Isn't it just something about just this? I'm just gonna submit the code.
Yeah, I mean, one way to think about it, like one way to do it is just like one way to try kind of sanity check this thing is just like start from the diameter case and like you need to grow the radius, right? And like just pick whichever sign like convention it is so that like you grow the radius from the diameter. Like the diameter has like is like the sum is small, the sum is too small or something, right? So that's like a good like I don't know litmus test or whatever for which half of the time you need to grow.
Okay, I'm just gonna start from scratch. I'll keep some of this, I guess. Oh my God, I guess I'll just sort this. And like this. Oh, I did something bad. R definitely needs to get bigger. Okay. Uh, I think this might be correct. I don't understand this code at all. Oh no, it's still not passing. Oh, it's the max area. This needs to be huge now. The radiuses can be really large. So if you're close to the degenerate, the radius is like actually humongous. Maybe just multiply this by another. And add a few iterations. If that doesn't work, maybe another couple thousand. All right, something tells me I'm not approaching this the right way. Hey, Andrew.
Yeah.
So I think I have a bug still.
Okay. Did you handle the is obtuse separately? Oh.
No, I tried to be cute, and I think that was a bad idea. Like, I don't think I
This
even
doesn't
have
seem-
this.
Is your radius correct?
No,
Is your
nothing.
radius correct in the not obtuse case?
It still passes all the cases that it used to pass, and now it passes one more. So that's probably one of the obtuse cases.
Okay.
But-
Maybe your area calculation is wrong in the obtuse case. Did you handle that correctly?
So don't you just subtract it instead of adding it?
Yeah, that seems right.
No. This is. Oh no, it's fine. It's fine.
Seems fine. You can probably use get max angle and that would just work because that would probably return a negative. But yeah.
I don't remember how angles work though. That's the problem.
Yeah. Did you? Okay. I mean, what is? Do the radii look sane?
Wait, I think there might be an issue. Are these angles actually correct? Like I wouldn't be able to do get max angle divided by 2 because this would need to be like, it wouldn't work. Because like 2, like let's say like 3 pi over 2 is not equal to negative pi over 4.
I mean, get max angle over 2 would just be pi minus val over 2. Like divided by 2 would just be pi minus val over 2, right? And so that would just give you the negative cosine. But
oh, it would work. You're right. Sorry. You're right. Sorry.
Yeah.
And I get rid of this. Okay, yeah, you're right. That is how it works. So this is probably where I messed up, I think. So first of all, I can just say R.
What's R?
The initial value, which is mx over 2.
And why are you? What is add?
This is my Penguin binary search.
But what does add initialize to? Like you have to go in 2 different. Oh, sorry. Add. Okay, sorry. It should always be at least that, right? Okay.
Add is, it's the biggest number I know.
Okay.
Is it big enough?
I don't know. I mean, is it? Okay, it's probably fine. I don't know. Should be fine. You can do the.
Arc sine of whatever.
Sure. I mean, it seems fine.
It's going to be like 500,000.
I mean, like, oh, so it passes all tests, right? Like, do the numbers look sane, dude? I mean, you can just print it, right? Like, just try it on like 1112 or 1112.
Sorry, one sec. Let me see exactly. Is it like this? Is this the number I care about?
I don't know. Oh, you're worried that it's not big enough? I guess.
It's definitely big enough. 500?
Yeah, I mean,
How
you
can it
wouldn't
only
be failing 8 cases. You wouldn't be failing 5 cases if you were if the number were just not big enough. But
you're right. You're right. I only need to multiply by a factor of 500 apparently. How can that be true? Shouldn't this be at least like, oh wait, I want a sine, right?
yeah. Asine is just, I don't know what you're
It's just you can approximate it as theta, right? Sine theta is theta.
Yeah.
Okay, whatever. I don't know.
think that's your problem.
So my problem is probably just a logical error with my sign.
I don't know. Just check your outputs and stuff. I guess I don't know.
Yes, I was doing this case 10, 10, 9, 20.
All right. Does it look right?
I don't know how to determine that.
I don't know, GeoGebra. Like, what's your radius? Like, your radius should be pretty easy to check, right? To print out.
Oh yeah.
Does that look sane? It should be smaller than 10.
It's bigger than 10.
That's right. It should be bigger than 10. Okay.
But barely.
Yeah.
Oh, I should print out is obtuse, but it's going to be obtuse for sure.
Sure. But I mean, yeah. I don't think you have problems there.
But I can see if it like converges correctly, I guess.
Sure, yeah. It should be a little more than 10. Okay.
So what I do here is in OK, I can just like say last sum with sum.
Also, why are you computing the areas this way? I guess your area thing is fine.
I need to add a cosine, right?
Sure. Yeah, I would have done like r squared sine theta or something over 2, but I guess whatever. Yours is probably actually a little more accurate.
R squared sine theta over 2.
Wait, also, did you set precision 2 on purpose? Did you submit more precision? Okay.
That's what they want. That's why it's 2 decimal points.
Oh, okay. Okay.
So I'm printing out my last sum of areas, and I can also do get max. That's strange.
Seems fine.
I don't know if that's fine. Oh, they add up to 2 pi. That's not true though. Oh wait, no, I'm being silly. Last sum is the one that needs to add up to 2 pi. And this is a bit more than pi, so that makes sense.
Yep.
And then if I do cosine of that divided by 2, it's a negative number. Just make sure. I'm pretty sure, but
yeah, should be fine. Yeah.
I'm still missing something. Yeah,
I'm not sure. And this passes all the old cases, right?
Yeah, I used to pass 1, 3, 4, 6. Now I pass 1, 3, 4, 6, 7.
Interesting. Equals LD1. Maximum total area.
Like this logic, doesn't make sense to me. Like I didn't think through it very clearly. So I'm pretty sketched out. I wanna write it down on paper.
Yeah, you can think it through. I'm pretty sure it should be correct.
I can't do this in my head. It's too confusing. So given a diameter and a bunch of segments, if the segments are too short, then we're gonna need a bigger radius. Well, we're always gonna need a bigger radius, but it's gonna be obtuse. Too long, if instead it was like this, then it's acute. And then when it isn't, when you know it's obtuse, now when the segments are too short.
I guess. Yeah, no, this should be fine.
No, I think it's the Jensen's thing, man. The Jensen's thing doesn't make any sense to me.
Why? Well,
I'm not convinced it's strictly monotonic yet.
no, you can convince yourself. I don't think it's very.
Wait, it's so tricky. Like, you're claiming that the value.
Like, look how well behaved sine is. Sine is just like x. Like it's not. It doesn't.
Can we write out the formula?
Yeah.
So sum of angles is sum of like arc sine.
Yeah, which is just x. Like a sine is also just x because sine is just x.
No, not when it's non-trivially large.
Sure.
So the angle is a sine of x over 2r, right? Let's just call it d.
Yeah.
Greater than, and when it's obtuse, it's going to be pi minus a sine mx over d. So really wait, what? Is it this? What am I saying? It's not that, it's just this. So you're saying increasing d will always say, like, make this expression larger? Assuming it's already positive. Is that your claim here?
Yeah. Here,
But why is that true? Like, it's not obvious at all to me that this is true. Like, I would believe you, but it's just like, I don't see the application of convexity here. No, it's smaller. You want this to be, you're saying it gets smaller?
Okay, let me just draw this in GeoGebra.
Oh, and you're saying given that sum of x is greater than mx. I mean, I believe when d is infinite that it's true. I'm not sure it's strictly increasing. I agree that the limits are definitely, as your radius gets infinitely large, you approach the degenerate case.
Yeah. I mean, I don't know. I don't have a like.
Can I plot this on Wolfram Alpha?
Actual proof, but like.
I'll plot it.
Yeah, here I'm plotting it in GeoGebra right now. It's 10, 10, 7, so that it's a little more. But like. Okay, like, I can. Oh, okay. Well, share this GeoGebra.
You want to share your screen?
Yeah, I guess I can share my screen. But you have to stop sharing. Here, I can just
wait. But do you see this diagram here?
Yeah, here, just look at this diagram. Like, how could this not be monotonic? Here, I share over.
No. Look, it's clearly not monotonic, even for the case you gave me, Andrew.
There's clearly one decision point.
It's bitonic. It's bitonic. Like, look at this.
The value?
The value of the excess angle.
Well, it clearly hits 1 at a single point, and then afterwards it hits 0 at a single point, and that's the point you care about, right?
Andrew, if you want, you can share your screen, so it shouldn't be a problem.
Yeah, I can share the screen. Like
it intersects 0. Like it stays
just
under.
Just look at this thing. It goes from like here, and then it crosses over, and you think it's clearly not going to wiggle around here.
Okay, I agree with that. Yeah, so like the expression I claimed was monotonic was not monotonic, but like
you claimed it's not monotonic, but it's like kind of not really the
right
expression. Like
it has one root. There's one root.
There's only one root is what you care about, and like it's.
And that's all we care about.
Yeah.
Okay, because it only has one root, we're never gonna.
Negative at some point, right? And so all you need to find is that crossover point.
And it only has one root because why?
Like, I don't know, under the right notion, it is monotonic. Like, I don't know, you probably want to define like the notion as like this arc length or something, or not this arc length, like maybe like, I don't know how far away B and F are, or something silly like that. Like you,
yeah,
it's true.
Why does it not wiggle?
Analyzing it that way is kind of tough, but you shouldn't really need to like dive into all the like formalisms about Jensen to believe this.
I mean, I believe you, man. I don't do math. Like, I'm very happy to just accept this as true. But then why is my code not working?
Well, that's a different question.
I'm not a mathematician. I don't care for the proof. If you say it's true, it's true. I must be doing something wrong still. Like, we need to increase R as long as it's not okay. That is true in both cases. Or we increase R as long as it's okay. Sorry, as long as it says okay, we increase R. And we start assuming it's okay. And if it's not okay, well, that means we have to flip to the acute case. That makes sense. So we start by assuming it's okay, which means we increase R as long as the arcs are too short. Yeah, I see no problem with the reasoning here now. Why does it still not work?
Yeah, I don't know. It looks correct to me. So it's probably something kind of silly.
Yeah, I could try the R squared theta thing.
Yeah, I don't know if that's really the issue though.
1/2 R squared theta. That is a better way to compute the area of an isosceles triangle.
Yeah, 1/2 R squared sine theta, right?
Yeah, and then I wouldn't have to divide by 2. I'll try that. Like, it's not going to make a difference.
Yeah, it shouldn't make a difference. It should be the same by like half angle or something, right?
Well, yeah, it's the same for a number of reasons. So I don't think it's worth resubmitting. Well, I still have like an hour, I think. That's a nice thing about these contests is you never run out of time. All right, could there be any other cases I'm missing? Like, perhaps the degenerate case is like, you're just supposed to clip it, but that wouldn't make any sense, right? Like, could it be that the obtuse case, you'd rather just clip the fence?
The obtuse case, you'd rather just clip the fence.
So that it's a diameter. Because like, it's not clear in the problem statement whether you can have excess fence or not. You know what I mean?
Yeah, I guess that's possible. Is that really? I don't know.
But then why? How did we pass case 7?
Right? You can run it. Like, is 10, 10, 10, 20 like bigger or smaller than 10, 10, 10, 21?
Oh, locally, I'm pretty sure. Oh, actually, I have no idea.
I don't really know off the top of my head. It's probably
20 is bigger. 20 is bigger.
Yeah, but I don't know. That seems like kind of a strange problem statement. Is that actually what? Like, I don't know. I can't see the problem, so it's all you to read the problem.
Farmer John has a long fence in hand, and he wants to use it to enclose some new pastures. The fence is foldable in certain points. Farmer John may construct a single pasture or several pastures from the fence in many different areas. Help Farmer John calculate the total maximum enclosed area that can be attained from the fence. The fence cannot be cut, and pieces of the fence cannot be switched. But it doesn't say that the endpoints must meet.
I feel like just take it as a polygon. I'm pretty sure you're doing the right thing, but just I don't know, screwing something or just screwing something up. I guess you're saying that it could just like you could just meet at not an endpoint. I mean, you can you can do that.
But why would why did I pass case 7 then?
I don't know. Could have been the equal to diameter case. Like, could have been the equal to diameter case. I don't know. You would have passed that before. I have no idea, dude. I cannot see the problem or your code, so I'm pretty useless here.
Yeah, let me share again. Let me share again. Problem and the code. My code has gotten pretty messy. I wouldn't be that surprised if I have a bug somewhere. This resize thing I did here is fine, right? To pop the back. Oh, I can also just say pop back. What am I doing?
Yeah. I don't know. Are your numbers big enough and stuff? Yeah, they seem fine.
I've LD'd literally everywhere. Some of this.
R equals mx over 2. I guess I don't know if it's a problem, but you could like now dividing and multiplying by 2 is pretty good. There shouldn't be any problems there. In theory, you might want to min things with 1, but it shouldn't really be a problem.
Min things with what?
With one prediction.
Where?
Like before you take a sign.
Oh, I see what you mean. So you don't get nans.
Yeah, but it's probably not the issue.
It could be. It honestly could be. But you're saying divide by 2 is just corresponding to incrementing the exponent, right?
Yeah. So it shouldn't really be a problem.
Who knows? Division algorithm might be really bad.
I mean, these are in the processor.
Just prevent nans. I think it's worth doing. But I don't think it's a bug. Yeah, it might be. It could be. That could be the issue.
Wait, where do you set is obtuse in the first run? Oh, it's initially set to true.
And then I reset it over here.
And then it like swaps. Is that how it works? So if it's actually obtuse, then it.
Then it needs to start getting bigger, right? If it needs to start getting smaller, well, that's impossible.
Yeah. Did you fail? Did you go back to failing 7?
Oh, I did. What the?
Well, I don't know. You could be.
What did I
Could be any
change?
number of things going wrong.
I changed the area formula.
Yeah. I mean, if you wanted to investigate, you should investigate thoroughly.
Oh my god, what is case 7?
I mean, is PP is PP to SDR?
It's macroed out. It's only in my if that's Steven.
Oh, you really should do do while 0.
No, it defines it as nothing. Oh, you mean just
You should define it to an empty block so that it like the
just in case.
So that no, don't put the semicolon. That's the point. It means the semicolon is still like exactly one statement or whatever.
Oh yeah, because right now is it like just having a bunch of semicolons randomly?
Yeah, exactly.
Is that bad?
It could screw with like your ifs, and if you're in the habit of writing ifs without new lines and stuff, it could be like a little weird. It's probably fine. It probably doesn't affect anything, but you know, I think that's the quote unquote like safe thing to do. I don't know. You don't use this inf thing, right?
Which one?
1000 left shift 20.
No, that's from a different problem.
Sure.
Yeah, I don't clean out my source code when I start a new problem.
Yeah, sure. All right, what does it say? It has 5 folding points, maximum enclosed area. It just says maximum enclosed area, right? Can I see the problem? Total maximum enclosed area. Wait, sorry. FJ may construct a single pasture or several pastures from the fence in many different areas.
I don't know what that means.
I'm pretty sure that means you're supposed to do this DP thing where well, first of all, it might mean that you do have to do the cut thing, but second of all, like, I'm pretty sure it means that like you can construct like several polygons that are like tangent to each other, attached to each other or something. I'm not really sure.
I don't think that's ever optimal
though. Okay, so it might be the diameter thing that you were saying. Like you should just if it's obtuse, then you should just reduce the max length down until it's exactly
It's never optimal, right? To have the thing, unless you can discard fence, unless you can discard parts of the fence.
Yeah, seems right. Yeah, I don't know. Maybe you're supposed to discard parts of the fence.
I don't really want to do that.
Just do like if is obtuse, then you just write a separate binary search. Like you just reduce MX down as you go.
I think what you mean is like we just start at 0. And then here we do min 1. All right, I just submit my old code with the min 1.
I don't think that's how it works, right?
Well, this might like cut off multiple things. Is it
still monotonic even? I don't know. I mean, you can try it. I mean, why not, right? But
oh wait a sec. It's not even true. Like if the max doesn't occur at one of the endpoints, then you don't even get anything from this. The max has to be either the first or the last element. Right?
Don't know what you're talking about.
They're giving you a chain, right?
Yeah.
And if it's true that you can like end not an endpoint, that means the first or the last element of the input can be reduced, but not anything in the middle.
Yeah.
I don't want to write this code because I don't think it's even the right interpretation of the problem.
Yeah, I mean, if there's a long one in the middle, I don't know. Are you supposed to like wrap the two sides? Like say like it doesn't even satisfy like triangle inequality. Are you supposed to like wrap the two sides and whatever
into themselves?
Yeah, like to create like this like I don't know infinity or whatever.
But like, wouldn't you provide that as a sample if it was going to be so complicated?
Yeah. Yeah.
Here, I can check if anything's degenerate pretty quickly. Like just while true, if it's degenerate.
Does it not give you RTEs?
You get nans, right?
What? Sorry, I meant does the judge not give you RTEs? Like if the judge just gives you RTEs, then.
I mean, you can TLE.
Like it doesn't tell you RTE though. That's kind of sad.
I think it also tells you RTE.
Well, then you should just do false instead of TLE, but just save everyone some compute cycles.
I guess. Yeah, I think the problem statement with the several pastures thing, like how would you construct more than 2 pastures? Is it like you can intersect yourself, but not at the, if it's not at a joint, it's okay?
Yeah, I'm not sure. So total enclosed area that can be tuned for the fence.
Can you cross a fence?
What do you mean cross a fence?
Like not that you'd ever want to, but can you like have fences just cross over each other?
Yeah, I don't know. I don't know why I have no idea.
Andrew, you're my last hope though. I could just take the 2.6 out of 3 and just
I mean,
end.
you can you? I mean, I don't know. You can do stuff like you can assert whether there is degenerate cases or not, right? Like, are there cases that don't satisfy triangle inequality?
It'd just be so surprising.
Yeah. If I don't know, you can try doing the thing where you just take the max and solve the diameter case. You might want to solve both. I mean, I don't know. Why? Just assert. Yeah, just assert whether it passes triangle inequality.
I'll submit the thing with the assert.
I mean, sorry. Are there submission limits here? I feel like you've been submitting a lot, right?
I don't think there's limits. No.
Well then, yeah, then.
There's no degenerate cases. There are no degenerate cases. But I'm just confused why. Huh?
Assert looks different.
I'm pretty sure. I mean, I could change it to while true. This one I've done before, so like I know it'll show.
I mean, you can. The other way to check if assert looks different is you just type assert false. And see why does that look different?
It doesn't.
Oh, sorry, but while true also doesn't look different than assert false.
No, it just didn't hit. This is when checking if there's a.
Oh, okay, I understand.
Degeneracy.
Yeah.
Okay, I'll delete this.
Yeah. Okay, so it always satisfies triangle inequality. The
convex case, is it the case that you can just do this min one thing?
I don't know. I don't think. I'm not sure about that. Not sure.
Not if you have to account for the endpoint thing, right? Like the endpoint thingy thing.
Yeah, something like that. I don't know. I mean, I don't know. If I were, if this were a real contest, at this point I would be extracting test data. So I don't really have any good advice for you.
What can you even extract?
Well, you can check whether it's obtuse or not, and like, assert is obtuse or whatever, or assert not obtuse.
All right, let's see which ones are obtuse. I'll do while is obtuse.
Yeah, sure.
I mean, I'm pretty sure all of them are obtuse. But
well, I mean,
we'll
it's a
find
good
out
test
if
anyways.
not.
Also, like, if your is obtuse is, implement the check is correct or not.
Yeah, no, that's a good point. Maybe I should have done the assert, but yeah, okay, they're all. Oh, test 10.
Yeah, I don't know. There are all these silly things, so I don't know. There's probably something really dumb. Yeah, so it could be like you should do the diameter thing. I actually can't really tell how you know when you need to make that trade-off. So I guess you just like try it.
Don't you always like obtuse? You always want to cut, right?
Yeah. Do you?
I feel like you do. If you're allowed to cut the largest one. Anyway, I'm not that invested in getting these last 4 test cases.
Yeah, I'm not sure.
I'm okay with just taking the L. I need to take a nap.
Yeah.
I'm like really sore from playing volleyball yesterday.
Yeah, it might just be the case where there are two. The case where there are like the like long edges in the middle is like kind of weird.
I could print out whether the max occurs at the ends if you want.
I mean, I don't know if that's, yeah, I mean, you could, but I don't know, even if it does, like, so if the max doesn't occur at the ends, there are two possibilities, one of which is like you just make one big polygon that's like concave, and the other is that you make like these two like more semicircular polygons. And I actually don't know in general which one is bigger. It might not be actually consistent. So you might actually need to check both, but I really can't tell at this point. I guess, yeah, if I were you, I would just write the subroutine which solves a semicircle, like given a polygon and a line that's long enough, just solve it and then just send that in. But
I'm not going to do that. It just doesn't sound worth it. Okay, so this was
but it's not
obtuse. I'm really lazy though. Oh, interesting. So only, yeah, no, Andrew, look, it won't help. I'm already passing the cases where the max is at the end.
What? No, but you can use that in the other cases as well. Like,
no, I don't think you'd ever want that. No, it's useless.
Why?
Like, why would you cut something that's not an endpoint?
No, it's like if it's very long, like, yeah, like you could either like have a very flat long polygon, or you could have two very like round semicircular polygons.
Oh, you're saying, oh, like just let it be degenerate, you mean?
No, well, yeah, you could either let it be degenerate, or you could do like, no, not that kind of cut. Like only like you essentially have the long one in the middle. Like you have the long one at the bottom, and the stuff to the left makes one polygon, and the stuff to the right makes a separate polygon. Yeah, so you have to decide between that and the degenerate one. And I think you might have just like try both, and that might be fine.
I'm just gonna go to sleep.
Okay.
Dude, this is like, I'm telling you, this is like a 1% chance of passing. It's not worth it.
I think it's more than 1%, but yeah, it might not be worth it.
Okay, let me read this problem one more time.
Several pastures from the fence in many different areas. What is that supposed to mean?
Okay, I'll give it 7%.
Yeah, I can't really tell. Because I'm pretty sure you did do the maximum polygon like correctly.
I also passed test case 7 at some point.
Yeah, well, you know, I don't know. These test cases work to 2 digits of precision, right? So if your answer is wrong, but like wrong in like just the perfect way, like it could be pretty close. So I'm not really that surprised.
But I already tried like plussing minusing 0.01.
Yeah, but you know, these are like silly apps. Like 2 digits, 2 decimal places is like almost nothing. I guess
so the only thing that I changed was the area formula, right? It wasn't the min of whatever. I can get rid of this.
I don't know what you changed. Did you not do you not have access to your old submissions?
I'm not sure I do.
Okay, well then I don't know. Then you might not.
I'll just try to recover it. Last thing I'm checking is to get that 7 again. So it was some bad math, right?
Area I mean, it was fine math. Yeah. It's like
R times cosine theta over 2.
Yeah. Times x over 2. Should be right.
No, divide by times 2. Let me just look at my diagram again. Area.
Yeah, I think that's right.
R squared, 1/2 R squared sine theta, or base times height over 2. Base x height r cosine theta over 2.
Yeah, should be fine.
Oh, there's also the
That's
sine.
MX.
I also changed the max aim, right?
Yeah, that could be the difference, but I don't know. If that's the case, then you just have some very screwy precision. Like, you're using long double, right?
Yeah. Oh no, I passed.
Okay, so is it just the area? What's wrong with this area formula? Oh, it's just you're not subtracting it, right? Sorry, is that the case?
Theta, sine theta is negative when theta is greater than pi.
Sine theta is negative when theta is greater than pi. Yeah. I don't know. I guess that just means you have some very strange precision issues. Like, you might be like suffering from some catastrophic cancellation kind of things, which would be pretty bad. Not there. Like, the issue is just you're subtracting areas. Like, you're subtracting like this big. Like, if your circle is very large, right? I don't know. You should have like enough precision though. I don't think you should get that bad.
I could do Pick's theorem.
Well, then you have to identify the points.
Or I would, that still wouldn't help, I guess, if the areas are that small. I would have to like do shoelace theorem, but in a really like find the origin that's like the center of mass, for example, instead of the circumcenter.
Yeah, that's essentially what you have to do. But then, like,
Shoelace.
I don't know. How do you? I don't know if you can get the coordinates that precise. You probably can, I guess.
No, I think the coordinates themselves are fine. It's once you start squaring things that then you lose precision.
Yeah. So it could be that.
It might be that. It's a precision issue at this point.
Yeah,
I could bring back this old code I have here.
Sure. I mean, I don't know, why not, right? You have no submit limit, so you should just submit limit.
Let's just divide it by R, maybe? No, that's not gonna help. Shoelace is the way to go.
Just
ankle.
Just subtract a little bit and submit and see what happens. But yeah, I don't know. If you want to, I don't really know what's the best way to fix this. I guess you can just calculate the coordinates of the points. It's just very annoying. Like, you just calculate the coordinate of each vector, and like you calculate the all the vectors of the side lengths, and then
yeah, it's not hard. Like, I don't think it's hard.
Yeah, it's pretty straightforward.
But here's the issue: R squared sine theta.
Yep.
Like, let's drop the R squared for now. We're just adding a bunch of sines together.
Yeah.
And you're saying that's where the catastrophic whatever happens?
Yeah, because your second sine is essentially the same as the first sine, right? And then you just multiply by this big ass number. Like, R squared is like R could be like, I don't know how big R could be, but I bet it could be like, I don't know, 1 billion or something. Actually, with 10 to the 9, with lengths at most 1,000, R probably can't get that large, right?
Like, the closest.
What's the total length? What's the bound on the total length?
500,000. You have lengths 1,000,
yeah,
number 500.
The largest edge is at most length 1,000, right? So it's like,
oh, true.
Be able to get like a huge.
Like, it'd be 1,001 over 1,000, right?
Something like that.
Max.
But that's not that big. Like, that's like kind of big, but not like absurdly
big.
That's
a good factor of 1,000. Yeah, that's a factor of 1,000 over your. It's like 1 million.
Yeah. You are using long doubles, right?
Yeah.
Okay. Well.
Maybe it is the right thing to do. Just wiggle it a bit.
Yeah.
I'll go +1 and -1. -1 gave nothing. +1 gave nothing. +2. This, by the way, for those watching at home, is called breadth first search. It's a very powerful algorithm that you can use to get a lot of extra points on your coding competitions. All right, I'm not very close. I've checked 1, 2, and 3 already. So this makes me doubt that's a precision issue.
Yeah, it might not be. I mean, like, once again, there are a lot of reasons why you could get, like, happen to get one case correct. So.
Wait, but all I'm changing is the R squared sine theta.
Yeah. So, I mean, like,
can you analyze the R squared sine theta?
Why one case could happen to be close but wrong.
But not okay. How close though? That'd be something.
There could be like, it seems plausible that like you're just like close, but like, yeah, the trying this is probably reasonable.
I'm glad I have your approval for
but
this
like
unholy.
the point is like if you actually have a bug, like, you know, like you could be like close but for the wrong reasons, you know. So I wouldn't put too much weight in like one case passing, right?
Well, it's passing when I change from sine to cosine. Sine never passes, even if I do +- 0.5. The cosine always passes. Case 7.
Yeah.
And the explanation there has to be this precision thing. I'm taking arc sine when I call get
right,
in.
right. But what I'm saying is that might not be your only bug. Like, yes, you might have some precision issues, but you might be getting lucky and getting close. And so twiddling some precision stuff like how fixes it instead of like the true reason, which is like your code is just totally wrong and you're getting close. You know what I'm saying?
But what I'm saying is that my code is totally wrong because of the precision.
Right, but
like it's clear.
Also be totally wrong for other reasons.
But isn't it clear that these two formulas are given different things?
They're giving slightly different things, but I don't know.
No, it's like different in the range of like 0.05.
Okay, so what's different about them? I mean, we can derive. So MX.
Well, let's try just the top half. Let's try the top one first. I don't know if it's MX or the other one. Okay, yeah, so it's the top one. Wait, no, it's the bottom one that matters. It's okay if the top one uses R squared sine theta. The bottom one has to use cosine theta over 2.
I mean, is the sign of this thing correct? Sine of negative theta.
I don't know. And these three are all obtuse cases, right?
Yeah. Sure. Well, I think this. Yeah, I think your sign thing is correct, but hard to say for sure. I mean, I don't know. Just like you have cases, dude. You can very easily just run some cases and check if they print the same number. Like, do you suspect it's like slightly wrong or like hella wrong?
Oh, you're telling me I have to generate cases?
Dude, you have cases like 10, 10, 9, 20.
I'm pretty sure those don't make a difference, but
well, how could a formula like this be like only like sometimes wrong? You know, like. Your thing isn't going to compile.
I don't know what I expected. Right?
So that seems like pretty okay.
I don't know what I expected.
Yeah, I don't know. Like, if changing this thing changed it, then you're like kind of off by, I don't know, some non-trivial amount or something. I'm not sure. Hard to say. Another possibility is like you're like doing integer arithmetic in some places instead of double arithmetic. I don't know if that's the case. That seems a little unlikely.
How would I pass any cases if that were the case?
Oh. Maybe some cases happen to be odd.
All right, do I have any ints here? I have n is an int, v is an int, I is an int. Oh, I don't use w anymore. This is from max is endpoint. This is checking if one of the first or last was an endpoint.
Yeah, I understand.
And it was not true.
Yeah, you can get, there's STD max element, which gets an iterator to the max element without having to sort.
Well, I already have the max thing, and I want to delete it too. And that's why I gotta delete it using popback.
Okay.
Don't you tell me there's something called erase or find. Like, I won't believe you if you tell me that.
Okay, so is obtuse.
Do I need an epsilon here? I don't. Pretty sure I don't.
I don't know. I mean, you can just do is obtuse XOR that thing or something if you want. But
I don't need to be more confused. I was talking about epsilon here. Like,
no, you don't need that.
That's what I thought.
Because it's like nice and continuous, right? You're not setting as obtuse, so.
Yeah, that's what I'm saying.
Are you doing enough iterations of binary search? Should be, right? 600 is way more than enough.
600 is like, yeah, the most overkill binary search I've ever written.
Yeah, I guess this binary search looks fine. Yeah.
That's how I usually write double binary search.
Yeah, it seems fine. Doesn't seem to be a problem.
What if I do r squared at the very end?
Sure.
It won't make a difference. It won't make a difference though.
I mean, yeah, I really can't tell.
There's like no reason to believe that would make a difference.
I don't know. You have like an hour left and you have some code. I would just like screw around and submit a lot of things, but it's kind of up to you.
No, I'm gonna take a nap.
Okay. And you're using R, which seems fine. You shadow R in some places. I hope you don't do anything stupid on that front.
Where do I shadow R?
Like you
R
here. And your parameters, which is probably fine.
Oh, let's just move this down.
You need to define is obtuse afterwards. Yeah. I don't know. There's still like a real possibility that it's just it's the thing with like you don't need to use the whole fence. I think that could explain a good amount of the stuff we're seeing.
No, we already did the thing where we checked if. Oh, the other thing.
I mean, the real thing.
The 7%, 7%, Andrew.
I mean,
are you increasing this to 17 now?
So. Maybe the code looks fine, right? I haven't really thought through your logic with the is obtuse stuff, but I think it's okay.
I don't know. I don't know.
I'll show you one.
Well, Andrew, thanks so much for the tips. I think this problem might just be beyond my ability.
Yeah, I don't know. It's kind of strange that we can't get it to pass. But, yeah.
It's okay. I'll read the editorial.
All right. Yeah, I wonder which of the solution. But yeah,
I think the 7% might actually be higher than 7%. I just really don't want to code that because I don't know how.
Yeah.
All right. See ya. I mean, it's like,
if it is that way, it's a very poorly worded question.
No, like, why would there be no degenerate cases if that were the case, right? Like, it doesn't make sense. It doesn't add up.
I don't know. Yeah.
Yeah. All right, Andrew. Have a great day. Are you gonna hang out with us more later?
Yeah, maybe. I also might stream on my own later. So we'll see.
Okay.
I gotta go eat lunch.
All right. See ya, Andrew.
Hey,
Oh,
Andrew,
hey,
thanks
Fatih.
for coming. And as Steven said, we have a panel, IOI panel at 4:45.
Yeah.
If you would like to join, let me know.
Sure. Sounds good.
Okay. Just 45 minutes. Thank you.
All right. Cool. Bye-bye.
All right, and Fatih, I think I'm gonna end my session here. I don't have the stamina I used to have,
That's
so
fine.
I need to take a nap.
I mean, you guys did. I mean, actually, you did yourself. Marvelous job. So you already finished 2 questions in the first half. By the way, let me. Okay, so did you find the surprise? Come on, the first question. So, okay, I'm suspicious about you right now. So, did you guys go to ICPC 2016? Do you remember the problems?
Is this like problem K or something, or one of the easy ones?
Okay, let me see. Just give me a second. What was the exact name of it? Let me see. Branch assignment. Do you remember branch assignment?
Oh, barely. I didn't. I like glanced at all the problems. This one we probably solved pretty quickly, right?
Okay. Yeah, the problems. Yeah, they were not IOI problems. The problems were prepared by one of the ICPC judges. So Dr. Osman I.
They did, you know what? They did feel like ICPC problems. I'll be honest. Like, I was gonna say, like, some of the problem statements feel like ICPC, like polygonal pasture in particular felt like an ICPC problem.
Okay. Yeah, it was from 2016. Okay.
Oh.
Okay. You did very well. We can stop live streaming right now. Thanks for watching, for everyone.